So it is an honor for me to introduce Vincent Hayward, my supervisor. He's a professor at Sorbonne University, Institute of Intelligent Systems and Robotics, a worldwide well-known leading researcher in haptics and robotics, author of hundreds of scientific works and patents, a member of the Academy of Sciences of France, and very bright and simply good person and mentor, I would say. So first of all, I'd like to ask some questions about your life, about your biography, just to get a glimpse of your interesting life. Then I can ask you some more scientific questions, let's say.
Okay, that's fine. Yeah.
Yeah. So if I remember correctly, you grew up in Paris in 1950s, the 60s.
That's right. Yeah.
Yeah, which was a completely different time. So can you describe that time?
Paris in the 60s.
Yeah.
Well, my probably the most prominent recollections are from the high school.
Mm-hmm.
You know, for the school, you know, the elementary school and the high school, and that was in the 70s.
Okay.
It was a time where, you know, the society was changing a lot.
Mm-hmm.
There was, you know, people would have hair like all the way here, and you know, you would have bell-bottom pants.
I see.
So that was the time, and yeah. So that's the it was a time of sort of freedom, and you know,
Yeah, I see.
and I was not a very good student at all, actually. I mean, okay.
Yeah.
And my profs would always say just enough to go to the next stage.
I see. But do you have some early memories, some interesting stories from your childhood?
Oh, from my childhood.
Yeah.
Well, that's a little hard. Yeah. I was. I guess it was. I must have been 16 or something like this, and then I had the chance to go and skiing in the Alps, and so that was fun. We just went with friends, and then for some reason, you know, you have these lifts.
Yeah.
And the lift was it's like a seat that, and then you have to jump, and then sit, and they take you away.
Yeah.
And somehow I was with a girlfriend,
I see.
and I was distracted, so I missed I missed the seat, and after 10 meters, I was actually hanging on the, you know.
Yeah.
And it was kind of scary because, you know, the ground was 10 meters.
And so how much time
Well,
I
had luck because actually the ground would go up to 3 meters, and I just let go.
I see.
So that was a fun memory, actually. And I didn't fall, actually. I managed to slide down back to the...
I'll see. And what about your family? I know that you had a brother. You have a brother.
I have a brother, yeah. He's a little older than me, yeah.
What about your parents? What did
my father was an engineer.
Okay.
In the oil industry, actually, in pipelines, and he was in a big later, you know, his second part of his career was actually running a pipeline from Germany to from the Mediterranean to the northern countries. So that was and my mother picked up studies later in life and became a speech therapist.
Speech therapist.
Okay. Specialized for deaf children.
Interesting.
So I was at home. There was always patients coming, they would learn how to pronounce, and
I see.
so I learned a bit of phonology and
Okay, I see. And what was your favorite subject at school?
physics.
Physics?
Yeah.
Okay. Okay.
Not history. It was really bad.
What you said. Okay. So, did passion for science manifest in early childhood? I remember you told me that you had some small laboratory under your bed.
Yeah. Well, it was not really. Yeah, it was like doing stuff. I would always go to places where people dump stuff like washing machines, and I would just take them apart and disassemble and then do stuff with the different parts. So it was kind of a mess in my bedroom.
I see. Okay. And so then you started your formal education at Nan Central School in
Yes, yeah,
1970s?
yeah. So it was a mechanical engineering school, and there was different. You had different options. You could do shipbuilding or fluid mechanics if you want. Can't remember. There was machine making, and there was an option called control, like automatic control. So since I didn't want to become too specialized in a particular area, this is the one I took actually.
Control.
And control and
I see. Then you moved back to Paris.
Then I moved back to Paris, and I was dead set of doing a academic career. And then somehow I was quite interested in the sense of audition. And I went to see a prof at Sorbonne actually at this time, who was well known in locally, but he was interested in musical instruments, how they work, the physics of a clarinet, or the physics of a violin, or and I went to see him. I said, I want to study percussions. How do the cymbals vibrate? And he said, that's interesting, but I'm retiring, so I'm not taking students.
I see.
So he told me I have a former student in Orsay who is doing speech synthesis. So I went to see the fellow who is still around actually, and he told me, yes, you can work on. We have a project actually that you could like. We have a speech synthesizer, but it's made of analog electronics.
I see.
So all op amps, and I still have pieces actually somewhere. And then the project would be actually that was in 75, I think. Yeah. Yeah, that was 75. And the project was actually to take that speech synthesizer, which is analog, and make it digital. But there was no computers then. I mean, you have no microprocessors. They were completely new, So I started building a processor from scratch.
Wow. To
do signal processing. Yeah. And at that time, the technology that was feasible was called a slice processor. So you would actually assemble a CPU by bit by bit, and in order to make it quick enough to process the signal at the audio rate, which the clock rate were really slow at this time, and then after 1 year he lost the funding, which happens. And I switched to another supervisor who had the project to do. it was a little original. It was like trying to improve robots. So the idea was, if a robot was programmed to do a task, how could you deprogram it and reprogram it automatically with a different processor?
Okay.
And so that's what I did. So eventually what I did for a PhD is a decompilation system. So he would take the code and then analyze it. It never went in practice because it was a little out there, a little crazy. But so that was it for the PhD. Yeah, decompilation. Yeah.
I see.
So I went from mechanical to computer science.
Yeah. And then you went to McGill University, as I remember.
Yeah,
correctly.
So, and then no, first I went to Purdue University as a postdoc. I had a fellowship from the CNRS in France.
Yeah, that's cool.
And I spent 2 years there doing robot programming. And my first robot was a robot that's still very interesting. It was called a Stanford arm. It's like a prismatic type robot, but it was excellent in design, very easy to change and did stuff including force control at this time. It was really really interesting, and then develop a computer program to run a robot application in Unix. That was and so I did a postdoc on this for 2 years, and then came back to France, and then was hired by the CNRS as a young researcher to continue that sort of computer-aided design / robotics. And then I grew tired of the administration, which is still very, it was still very heavy, and I looked for a job in America, and the first one that answered.
I have another question. Why America?
Oh, because I really liked it. Having spent 2 years there, the spirit and the spirit of doing stuff, and and so I got hired by McGill on soft funding for a couple of years. That's in Montreal, in Canada, and then eventually became a assistant professor. Yeah.
I see. Okay.
It took a long time. Between a PhD and then actually the position.
Yeah, but there were so many hippies in that time.
Yeah.
So did you hang along with them, or?
No. Then I was no longer a hippie.
Okay. Then at some point you decided to research in haptics.
Yeah. So that first I did a lot of sort of conventional robotics, like kinematics and control.
Yeah.
Some design, and something that was noteworthy was we had a contract with Hydro-Quebec, which is a utility company in Quebec, to make a robot that would have the same size of a human arm and the same strength. So it could lift, so it was made of hydraulics. It was running on hydraulics, and it was really a very interesting project, very fast and dexterous. And then of course, like many things, the money ran out, and then I went to do some other stuff, and then I met a guy in the national labs in Montreal, who was interested in accessibility. And so that was in 98. in 98. And then we were talking about different things. So I'm working on a system for the blind.
Yeah.
To put things in context is because at this time, the computers were run with DOS. So like Unix or DOS, basically. So for a blind person, it's no problem because you have a braille display, and then you can program the computer with one line. Because it's one line. And then Windows came around, and that's a big problem because then the computer scientists or computer employees who were blind couldn't use Windows anymore. So what Christophe had designed is a system where you would move the mouse, and then the icons on the screen would talk. And they would talk, and they would tell where they are, all by the speech, automatic speech, actually, which was by that time quite highly developed, actually. And then there was other ideas also, like when you moved an icon, it would make a friction noise. It would be like a whoosh. And then I saw the stuff, and I said, yeah, well, that would be interesting to do. To augment the interface with haptics, which was beginning to be a little bit of a research interest in late 90s. And then and that's how I got interested in the topic.
I see.
Actually, the device is still here on the shelf.
Maybe we can
look at it later.
Yeah, definitely. So as we see, like when you start your career, the path was not so smooth, I would say.
No,
so
the least you can say.
Yeah. What kind of challenges did you run into?
Oh, it's probably it's my character. I just like to do more different things.
My next question is, what is haptics in simple terms?
Oh, well, It's a term that was invented like at the end of the 19th century. So it's pretty old, actually, and it's from a Greek root, and it came from Germany, which at this time had a very strong school in psychology, and like an influential psychologist at his times thought that the sense of touch was very interesting, as interesting as vision or audition, and but it was missing a term, because in vision you essentially it's based on optics and on how light propagates and reflects off surfaces, and acoustics is the basis of audition and how sound waves propagate, and there is no term for touch, actually. So that's how the word haptics was introduced as a counterpart to optics and acoustics. But initially it had a very broad meaning. It meant there was at this time there was much less emphasis on trying to take phenomena, especially in biology, as small components which are put together. It was a much more comprehensive view about a particular function, and so what haptics meant at this time was the guidance of hand, because if you don't have the sense of touch, you cannot manipulate objects. You cannot move your hands properly against objects. And so that's what it meant at this time, which is actually totally correct.
Yeah,
it's really what it is. It's So haptics is the sense of essentially that lets you manipulate objects, know what they are, if it's leather, glass, if you can grasp it, if it won't fall of your hands and so on.
I see. So among touch, vision, and audition, I think haptic is the less explored sensation. And what is the reason for that?
Well, that's a question that's been asked many times. Well, it's because it seems like our world is it's very dominated by vision. It is the case. There is no question about it. and then next, of course, come audition, because audition is speech. So if you know, it's obviously very, very important. It's speech and music. Beyond basic functions that locating objects and identifying objects. But and touch is much. It doesn't have this quality at all. It's really much more. It's about doing things. And so there is no obvious, not cultural component, if you want. You don't communicate by touch except for rather simple things like shaking hands and effective touch, but it nowhere can be compared to speech.
Don't have touch, you cannot walk.
Yeah, exactly. So if you don't have it, your life becomes. I mean, it's can happen. It's very rare. There, of course, there is a proportion of people who lose sight. They become blind for various reasons. You can become hard of hearing or lose your audition at different stage of your life, possibly from birth. But touch, somehow it doesn't happen. There are very, very few cases, and I know a few, of people who are asomatic, that they don't feel. But it's very, very rare. One case is a hereditary problem, if you want, in the way the genes express themselves, and then you don't have the cells. But it's really, really not prevalent at all. And then so the reason is, the consequence is that people take it for granted. It always works,
I see. So for vision, we have really high quality, let's say, screens, and for audition as well, we have really powerful, let's say, technologies. But when will we be able to design that kind of powerful devices for haptic applications as well? Or is it possible?
I don't think it's possible, actually, because it's not a good question. Audition and vision, no, they rely on transmission of energy at distance. Like you have light, and and then same for sounds. You can have a sound source, and you can rather simply reconstruct a approximation of the acoustic field. Even with something very simple like a phonogram. But for touch, you can't do that. There is not one, if you want, method for recreating the tactile field. It can only be by approximation in specific fields or specific applications. So it's hard to imagine having a speaker for touch, because there are so many kinds of touch also, as you said. It's indispensable for walking. It's indispensable for holding objects and knowing what they are, their weight, and so on.
Mm-hmm.
And there is not one simple transducer that will do all these different tasks.
I see.
It can be done, application
Mm-hmm.
by application, but not across the scale.
I see. Okay. Mm-hmm.